All right, today we're going to finish up section 5.3, continuing to solve polynomial equations by factoring. But our technique today is to look at factoring quartics. Those are the ones that have an x to the fourth in them. And we're looking at specific quartics that we refer to as being in quadratic form. That means they're not quadratics, but they kind of resemble them in terms of how they would factor. So we're looking at quartic functions that have this pattern. They have an x to the fourth as their first term, an x squared in the middle, and then a constant. So these are all going to factor into the form where we take that x to the fourth and we split it up. So just like when we had an x squared, if we'd had this quadratic, we would have split up the x squared into x and x. And we would have looked for two numbers that multiply to be 9 and add up to -10. Well, we can do the same thing with an x to the fourth. We can split it up and put two of them in each one. And then we can do the same thing where we say, okay, well, what numbers multiply to be 9? 1 and 9, 3 and 3. They can be both positive or both negative. Since our middle term is negative, we need them both to be negative. And we need two numbers that multiply to be 9 and add up to -10. So we would use a 9 and a 1. Now, these both are what we call differences of squares. And remember, we can factor those further. So x squared minus 9 would factor into x plus 3 and x minus 3. That's how we get that middle term to drop out. This one factors into x plus 1 and x minus 1. And now we can set each of those equal to 0. So x plus 3 equals 0 means x would have to be -3. X minus 3 could be the 0, then x would have to be +3. Here x plus 1 could be 0, so x would be -1. And here, x minus 1 could be 0, so x would be a +1. Okay, now, there was an alternate way we could have done that one. We could have gone from this step and solved by square rooting. Here we solved by factoring. So we factored it another step. If we solve by square rooting, we would say, okay, well, if x squared minus 9 has to be the 0, or x squared minus 1 has to be a 0, we're going to add the 9 over and square root both sides. So we get x equals plus minus 3. Here we would add the 1, square rooting. We get x equaling plus and minus 1. So we're getting the same answers. A positive and a -3 and a positive and -1. And it doesn't matter which of those two methods you use to finish that one. All right, our next one, we have an x to the fourth for our first term and an x squared in the middle. That means it's that quadratic form where we take the x to the fourth and we're going to split them into 2 and 2. We need two numbers that multiply to be 12. So 1 and 12, 2 and 6, 3 and 4. And we want them to add up to 7. So we're going to use the 3 and 4. Now, for this one, we have to solve with square rooting, because these are not a difference of squares. We can't factor those anymore. So let's take x squared plus 3, set it equal to 0, and x squared plus 4, set it equal to 0. We're going to subtract the 3 over, and then square root. So we end up with x equaling plus minus I root 3. For the other one, we're going to subtract the 4 over and square root. So we end up with x equaling plus minus 2i. So our solutions, we have 4 of them. And remember, if it's an x to the fourth, there's 4 answers. We have a positive I root 3, we have a negative I root 3, we have a positive 2i, and we have a negative 2i. All right, so how can you generalize a factor that's going to give you real numbers? It's going to have a minus in there. And how do we generalize a factor that's going to give us imaginary numbers? It's going to have a plus in there. Okay? So when we subtract it to the other side, it ends up being negative, which gets us our imaginary answers. All right, so what's the first step for these before we can factor? The very first thing we have to do is make sure that it's equal to 0. Okay, so we have to get one side to be a 0. So let's subtract the 25 over. And then let's go ahead and try to factor this. Our x to the 4th, we're splitting into x squareds. We need two numbers that multiply to be negative 25. So negative 1 and 25, positive 1 and negative 25, or negative 5 and positive 5. We want the pair that adds up to negative 24. So we need a positive 1 and a negative 25. Okay, so this one, we could factor more if you want. This one we have to square root. All right, so for the first one, we would take x squared plus 1 equals 0. Because of that plus sign, we know we're going to get imaginary answers. We're going to subtract the 1 to the other side. We're going to square root. So we get x equals plus minus 1i. Square root of negative 1 is an I. For the other one, if we go ahead and solve by square rooting, we're going to add 25 to the other side. We're going to square root, but this time we are square rooting a positive 25. So we just get x equaling plus minus 5. So we get two imaginary and two real answers. All right, go ahead and pause the video and try this next one. Remember, we have to get one side equal to 0 first. Once you have it solved, go ahead and turn the video back on. Okay, let's check. We should have added the 49 over to the left side. We then factor it, splitting up our x to the 4th into x squareds. We need two numbers that multiply to be 49 but add up to negative 14. You should have had both of them being negative 7s. Setting them equal to 0, since they're the same, we're going to get the same answer for both of these. We're going to add the 7 over, square root. So we get x equals plus and minus the square root of 7. So because both of these factors were the same, we would have had two of these expressions. In other words, we could have done the same thing over here. So we're getting two positive root 7s and we're getting two negative root 7s. So both of them have a multiplicity of 2. They're occurring twice to account for our 4 zeros. All right, our last question is a little bit of a challenge because notice it has an x to the 5th. But also notice that there's an x common to all of these. So we could factor an x out first. We could take that x out and we have an x to the 4th plus 3x squared minus 4. And now it fits that quadratic pattern. So we'll split up our x to the 4th. We need two numbers that multiply to be negative 4 but add up to a positive 3. So we would need a positive 4 and a negative 1. And now we need to set each of these factors equal to 0. So x could be a 0. That one's already finished. Or we could have x squared plus 4 equaling 0. We would subtract the 4, and we would square root. So square rooting both sides, remembering your plus minus, we would get the square root of negative 4, which would be 2i. So we get x equals plus minus 2i. And then the last part, we have x squared minus 1 equaling 0. We're going to add the 1 over. Again, we're going to square root to get x by itself. The square root of 1 is just 1. So we had a degree of 5, and x to the 5th. That means we had to have 5 zeros, and we do. Our zeros are 0, 2i, negative 2i, and 1, and negative 1. All right, so for today's homework, you are going to be working on worksheet 5.3D.